Good afternoon, all.
Good afternoon, ma'am.
I think today is the first paper for backlog exam. Yeah. Uh, so, attempt it sincerely. Okay. Now, in today's session, we are going to discuss about last practical. Okay, we are going to conduct. Actually, I wanted to take 8 experiments only, but now we have decided that we will take 10 experiments. So, this is the last experiment that we are going to conduct today. That is VHDL code for ALU. That is a arithmetic logic unit. Now, can anybody tell me what is mean by ALU?
It is the device in which we can perform arithmetic as well as logical operations.
Yes. So the unit which in which we can perform arithmetic as well as logic operations, that is a arithmetic logic unit. That is a ALU. Okay. So we are going to write a VHDL code for this ALU and then simulate it. Okay. So I'll share my screen now and let us open Xilinx. Okay, we'll give name to this as a ALU. Uh, this is the source that we are going to have for this as a HDL, so that we have selected. Then, as you know, we need to select family, then device, that all things that we have already done. And so by default, whatever we have selected earlier, that will come in this window. So that is a new project wizard. So which are the where we can get the project settings. So here we have selected the language, that is a VHDL, because we are going to write this code in a VHDL. As you know that in the Xilinx we can have Verilog programming also, but right now we are going to do VHDL programming, so that we are doing here. Okay. Then we have selected Spartan 3E family. Then device, that is XE3S500E, that we have selected, and package of this is a VQ100 package that we have selected. Okay. Then after that, click on next. Okay. Here you will get the summary of your project. So click on finish. This is the usual process that we have done, and then click on this project name, that is a ALU that we have selected here, and click on new source. Now, as we want to write a VHDL code, so select VHDL model for the source and give the name to this. So I'll give the name to this code as a ALU. So this source, that is the ALU, and then we are going to write a VHDL code for this uh, arithmetic logic unit. Okay. So now here we want to perform arithmetic operation. So how many input ports will be there? We want to perform certain arithmetic operations. So how many input ports will be there? Minimum input ports. ऍक्च्युली म्हणजे मला काय करायचंय, मला एक सर्टन कोड असेल तर मला ऍडिशन करायची आहे, अदरवाईज मला सबट्रॅक्शन करायचंय, किंवा मला एंडिंग करायचं आहे इनपुट्स मध्ये, ऑरिंग करायचंय. ओके, सो लाईक दिस ऑपरेशन्स आय वॉन्ट टू परफॉर्म. सो हाऊ मेनी इनपुट पोर्ट्स विल बी रिक्वायर्ड इन दिस कोर्स?
मॅम हे सगळे ऑपरेशन तर दोन ह्याच्यामध्येच होतात ना, ए किंवा बी. ए बी हे इनपुट.
Okay, so that means at least minimum we require two inputs. Okay, so let us say we have the input that is A and B. Okay. Then actually we want to select certain uh, operation. Okay. So for that we will require a select input. So म्हणजे ज्याप्रमाणे सिलेक्ट इनपुट जसं असेल त्याप्रमाणे आपण ऑपरेशन्स परफॉर्म करणार आहे म्हणून त्याच्यासाठी आपल्याला सिलेक्ट इनपुट लागणार आहे. ओके. नाउ हियर वी आर गोइंग टू टेक इनपुट 4-bit input. So we will select this as a bus, okay, and then MSB that is a 3 and LSB 0. Okay. Then we are going to select B also 4-bit. So this will be 3 down to 0. Okay. And now here we will select this also select input as a bus, and here we are going to take this as a 3-bit select input. Okay. So that means 8 operations that we are going to perform. So for that we require 3 input lines. So here 2 down to 0. So that we are going to select. Okay. And then output. Okay. So this is the out, and then here also as these inputs are 4-bit, that means output should be also 4-bit. So here this will be MSB will be 3 and LSB will be 0. Okay. Click on next. Then click on finish. So here you will get this type of skeleton for this your code. Now actually here you can see that data type is a std underscore logic underscore vector. Okay? But we want this different arithmetic operations that to be performed, and so number may be signed number also. So instead of having this data type as a std underscore logic underscore vector, we will change this data type to signed. Okay? So this will be a signed input data type. So this is also we are going to change as a sign. Okay. And then obviously this output will be also of a signed. Okay. Now as we are going to perform different numeric operations, so with this package, that is a library package, that is IEEE.std underscore logic underscore 1164. We need one more package, that is a numeric underscore std. Okay, so that also we are going to add. So this is a IEEE.std and sorry, numeric underscore std. .org. Okay, so these are the packages that we have added in this code. Okay, so these are the input ports as well as output port, and then we are going to write a code to in an architecture. Okay, so now what we want to perform, we want if select input is 0 0 0, then we want there should be addition of input ports. Okay, that means A plus B operation should be performed. If there is a 0 0 1, then we want A minus B operation. If there is a 0 1 0, we want A minus 1. Okay. If there is a 0 1 1, then we want A minus A plus B. Then 1 0 0, A and B. Then 1 0 1, A or B. 1 1 0, not A, and 1 1 1, A XOR B. Okay, so these operations that we want to perform whenever there will be a different code at select. Okay, input. So for that, what we will do, we will write a process here. So in this architecture, we will have process. And for this process, sensitivity parameters will be A, B, select. Okay. So depending on the variations in these parameters, there will the statements which will be followed will be executed. Okay. So here beginning of this process. Now here we will use a case statement. So case ACL is, and then when it is 000, then what we want to perform, output should be equal to A plus B. That means we want to add two numbers. Okay. If it is a, when select input is 001, then output, actually we have just out, so this should be out only, is assigned as, okay. So can anybody tell me what is the error in this code? Actually I can see here one error. Hello, am I audible?
Yes, ma'am.
Okay. Okay. Can anybody tell me what is the error in this code right now? Just आतापर्यंत आपण जेवढा कोड लिहिलाय त्याच्यामध्येच एरर आहे. कोणी सांगू शकेल?
मॅम ते वेन 001 आहे तिथं डबल कोट कंप्लीट नाही केला तुम्ही, कोलन आहे तिथे.
Okay, yes, that is the one error. But one more mistake I have done. कोलन तर नकोच आहे. That is a big mistake I have done actually. मी इथे आउटपुट साठी काय वापरले, OUT. Okay, but this is a keyword in a VHDL, and as we know that we cannot use a keyword as an identifier. Okay, so for any parameter we cannot use this keyword as a identifier. So here this should be output. Okay, आपण कुठेही कीवर्ड ॲज अ आयडेंटिफायर म्हणून नाही वापरू शकत, त्यामुळे इथं पण मला चेंज करावं लागेल. सो दिस शुड बी आउटपुट अँड देन इट इज अ ए मायनस बी. देन नेक्स्ट इज अ when 0 1 0, what we want to perform, we want output should be equal to a minus 1. Then when it is a 0 1 1, output should be equal to a plus 1. When it is 1 0 0, output is equal to a and b. For 1 0 1, it is output is or B. Okay, so any operations that we can perform for particular code. So we have assigned these codes only. So these are the different uh, cases that we have used. But suppose if there is a certain another case, so for that we will have the syntax like for others. What we want to perform, there should not be any action. So for that we will use the instruction that is a null. Okay. Then end of this case and then end of process and then end of behavior. Okay. So end of this architecture. So this is the code for ALU. So let us save this. Okay. Then synthesize. So our syntax that has been uh, completed successfully, checking of that syntax. Then let us see RTL schematic. So this is the RTL schematic. So when we clicked, okay, actually earlier was the outer view and then this is the internal circuitry there. Okay, so now after that, as our syntax checking that has been completed successfully, so we are going to simulate this program. And as you know that whenever we want to simulate any VHDL program, we need to write a test bench for that. Okay, so let us write a test bench. So click on this and then right click on this and select new source. We want to write a VHDL test bench code. So select source type as a VHDL test bench and then give the name to that. Okay, so let us give name as a ALU underscore test TB. Click on next. We are going to associate this with the source that is ALU. So select that one and click on finish. Let us close this RTL view. Now here you will get a skeleton for this test bench. So here we are having a library declaration part. So here actually we want this live package also that should be added. So I will decomment that. So as earlier it was commented. So I have removed that and we are going to use this package also in this code. So this I have used package that is IEEE dot numeric underscore std dot all. Okay. Then this is the entity declaration part for this test bench and then in architecture you can see here all these this component ALU, okay, and ports of that component. Now as you know that in a earlier code that is a VHDL code we have selected this A as a signed number. Okay, so type for this is a sign. So let us select this as a sign. B is also signed and output is also signed. Okay, then end of this component. Now here also we need to change. इथे पण आपल्याला चेंज करायला लागणार आहे कारण इथे पण एसटीडी अंडरस्कोर लॉजिक अंडरस्कोर वेक्टर आहे पण आपण काय यूज करतोय साइन टाइप यूज करतोय सो दिस इज अ साइन ओके पण लक्षात ठेवायचं की आपण सिलेक्ट मात्र एसटीडी अंडरस्कोर लॉजिक अंडरस्कोर वेक्टरच वापरतो तिथे आपण डेटा टाइप साइन नाही वापरत आहे आणि आउटपुट साठीच पण चेंज करायचं ओके सो ऑल द चेंजेस दॅट वी हॅव डन जेव्हा जेव्हा तुम्ही टेस्ट बेंच वगैरे लिहिणार आहे किंवा कोड लिहिणार आहे बाय डिफॉल्ट तो एसटीडी अंडरस्कोर लॉजिक डेटा टाइप घेतो ओके सो म्हणजे लायब्ररी IEEE हे जेव्हा आपण सिम्युलेशन करतोय किंवा तुम्ही कुठलाही कोड लिहिता तो बाय डिफॉल्ट एसटीडी अंडरस्कोर लॉजिक घेतो म्हणजे वेक्टर किंवा जस्ट अ सिंगल बिट जे काही डेटा टाइप असेल तो पण आपल्याला जर दुसऱ्या टाइप मध्ये घ्यायचं असेल तर आपल्याला चेंजेस करावे लागतील सो आय हॅव चेंज ऑल दिस डेटा टाइप नाउ वी हॅव नॉट यूज्ड क्लॉक सो आय विल कमेंट दिस we can delete that part also okay so here these are the port mapping so A is mapped with A so all the ports that are mapped as okay also as we are not going to use a clock so clock process is also not required so I'll delete that and then stimulus process. Okay, so I'll minimize this time period. So I'll make this as a time period as a 1. Now, I will initialize A and B once only. ज्या काही Aच्या आणि Bच्या व्हॅल्यूज आपल्याला द्यायच्या त्या एकदाच देईल आणि त्याच्यानंतर फक्त आपण सिलेक्ट इनपुट चेंज करूयात आणि मग आउटपुट काय येतं ते चेक करूयात ठीक आहे सो we will assign value A okay so tell me any 4-bit number for A hello
1100
1100 okay B okay, tell me another number
1010
1010 okay. Now let us select so let us start from 000 to 111 okay so 000 okay we'll wait for 10 nanoseconds so okay and then we'll make changes so I'll copy this कारण आपल्याला हे 8 वेळा लिहायचं आहे so I'll copy and okay paste so CL so now I will make it as a 001 again I'll make it as a 010 011 100 101 110 and 111 okay so all the operations that we are going to perform with the inputs that is A is equal to 1100 and B is equal to 1010 now whenever select input is equal to 000 then it will perform addition of these two numbers whenever it is a 001 it will perform subtraction of these two numbers then for 1010 it will be A minus 1 minus 1 for 011 it is A plus 1 then it is for 100 it is AND operation 101 it is a OR operation 110 not operation and 111 it is a XOR operation. Okay, so these operations that we are going to perform now, again, as we have not used clock, so I'll comment this statement. Okay, and then as usual, this is the wait statement. That means it will be continued for the next simulation period. Okay, and then end of this process, that is the stimulus process, and then end of this architecture. Okay, so let us save this. Okay, and we are going to simulate this. So select simulation in the view, then click on expand this iSIM simulator, click on behavioral check syntax. So there is a this should be okay. So behavioral check syntax that has been completed successfully. So let us simulate this. So whenever 800, okay, we have initialized this to 1100, but initially this value for A is a 000, 0. B is also 0000. So output that, and select input is also 000. So output is 0. Okay. Now here we have made A is equal to 1100 and B is equal to 1010. Now select input, that is a 000. That means it will perform addition of these two numbers. Okay. So now what is addition of 1100 and 1010? Hi, the addition 1100 plus 1010. What is addition? Jnaneshwari? Avinash? What is addition of 1100 and 1010? This is a very basic question of digital electronics. अरे किती येते ऍडिशन 1100 आणि 1010 ची
22.
okay in a binary number it will be 10110. Okay, so as we have output of 4 bits only, so it will store only last 4 bits and the carry that will be discarded here. Okay, so you can see here the result, that is a 0110. Okay, now here you can see this as select input is 001, it will perform subtraction operation, that means a minus b. Then here for 011 it will perform a, sorry, for 0 1 0 it will perform a minus 1. So here it will be 1 1 0 0 minus 1. So it is a 0, 1 0 1 1. For 0 1 1 it will perform a plus 1. So you can see here 1 1 0 0 plus 1, that is a 1 1 0 1 output. Okay. Then for 1 0 0 it is a AND operation. So 1 1 0 0 0 ANDed with 1 0 1 1. So it will perform bitwise ANDing operation. So 1 and 1 it will be ANDed as a 1, 1 0 0 0 1 it will be 0 and 0 0 0. So you can see the result, that is a 1 0 0 0. For 1 0 1 it will perform OR operation. Okay, म्हणजे जे काही 1 1 0 0 आहे ते bitwise OR होणार आहे कशा बरोबर 1 0 1 0. So output will be 1 ORed with 1, that is OR 1, 1 ORed with 0 1, 0 ORed with 1 1 and 0 0, that will be giving your result, that is a 0. So you can see here result, that is a 1 1 1 0. Then for 1 1 0 it is a not operation for A, so not A, so that means 1 1 0 0 inverted output you will get here. So it is a 0 0 1 1, and for 1 1 1 it is XOR operation. So you can see here it is giving high output only both the inputs are of different logic level. The same logic level चे असतील तर 0 मिळणार आहे, त्यामुळे 1 1 0 0 आणि 1 0 1 0 चा रिझल्ट तुम्हाला मिळणार आहे 0 1 1 0. Okay. So this is a very basic ALU circuit that we have performed today. Okay. So this is the VHDL code for ALU. That is a 4-bit ALU. Okay. If anybody has having doubt regarding this, कुणाला काही डाऊट आहे का याच्याबद्दल? Is there any doubt?
No, ma'am.
Okay, this is a very basic circuit for ALU. Okay, but whatever is the ALU that is in your laptop or in your mobile, that is a smartphone, it is a it is performing very high functions, different functions it is performing, too many functions it need to perform. So त्याचा तुम्ही जर तो प्रोसेसर बघितला तर तो खूप मोठा आहे तो, पण इथे म्हणजे त्याचे ऍक्च्युली मोठा इन द सेन्स नॉट इन द साईज, पण त्याच्यामधले जे फंक्शन्स आहेत त्याच्यामधले जे त्यामुळे ट्रान्झिस्टर्स नंबर ऑफ ट्रान्झिस्टर्स आहेत ते खूप जास्त आहेत. पण आपण आता इथे जो केला आहे तो फक्त एकदम सिंपल बेसिक आहे. ओके, ज्याच्यामध्ये आपण 8 ऑपरेशन्स परफॉर्म करतो. सो but whenever we saw a RTL schematic for that, okay, or I'll show you a technology schematic. So you can see here. So this much is the internal circuitry for this ALU circuitry. Okay. त्यामुळे तुम्ही लक्षात घ्या की आता जर आपण दुसरा कुठलाही म्हणजे तुमच्या स्मार्टफोन मधला जो काही प्रोसेसर असेल त्याच्यामध्ये आतमध्ये केवढं सर्किट असेल that you can imagine here. Okay. So this is about the arithmetic logic end. Okay. So if anybody is having doubt, they may ask. This is the last experiment that we have performed. Okay, I will share lab manual today. Okay, in your study material sheet. So from that, what you need to write? You need to write a one-page report for each of these experiments. So in that, you need to write a name of the experiment. Then you need to write a VHDL code. You can draw a RTL schematic. Okay, तिथे तुम्ही schematic काढू शकता. त्यात तुमचे इनपुट आणि आउटपुट पोर्ट्स आहेत तर त्याच्याप्रमाणे काय आउट तुम्ही बघितलं ते तुम्ही तिथे ड्रॉ करू शकता. अँड देन now it is not possible to simulate this code for you right now. Okay, so you can draw just waveforms that you have observed. हे तुम्ही कुठलेही इनपुट घेऊन त्याप्रमाणे तुमचे जे काही आउटपुट येऊ शकतं, प्रोबॅबल आउटपुट. सो त्याप्रमाणे तुम्ही ते ड्रॉ करायचं आहे. ठीक आहे. सो दॅट 1 पेज रिपोर्ट यू नीड टू राईट फॉर इच ऑफ द एक्सपेरिमेंट. म्हणजे आपण जर 10 एक्सपेरिमेंट परफॉर्म केले तर तुमचे 10 पेजेस रिपोर्ट कम्प्लीट असायला पाहिजे. सो यू नीड टू सबमिट दॅट. ओके. So now you can see that here participants are only 55. That means out of that, 2 are participants are from my side. Okay, because I have joined from 2 accounts. So here that means 53 were present. Okay. Now those who are absent, if their attendance is below mark, then they will be detained for this subject. Okay, म्हणजे प्रत्येक सब्जेक्टला जर तुमचा जो काही अप टू द मार्क नसेल तुमचा अटेंडन्स, तर तुम्हाला रिटेन केलं जाईल आणि मग तुम्हाला एक्झामसाठी प्रॉब्लेम होईल. सो अटेंड ऑल लेक्चर्स सिन्सिअरली. प्रत्येकाने अटेंड करा. उगाच म्हणजे तुम्हाला प्रॉब्लेम नको यायला याच्यासाठी आम्ही प्रिकॉशन्स घेतोय, पण तरीही तुम्ही सिन्सिअरली अटेंड करा. ओके. जर काही प्रॉब्लेम असेल तर आधीच कळवा. म्हणजे आता एक्झामसाठीचा जर काही प्रॉब्लेम असेल त्या दिवशी, तर तुम्ही आधीच तसं कळवा की तुमची ज्या दिवशी एक्झाम आहे. ओके. सो इज देअर एनी डाऊट?